The most distant human-made object is NASA's Voyager 1 spacecraft, which has managed to reach interstellar space. Imagine launching a spacecraft 45 years ago and still exploring areas it was never thought to reach, well beyond its scheduled lifespan. That's the incredible reality of a NASA mission that is redefining space exploration. But there's something even more fascinating. This brave spacecraft is not only millions of miles from its launch point, but it continues to send data back to Earth using technology older than that of a cassette player. That's not all. The spacecraft, launched in 1977, just made a discovery that has shaken the scientific community and captured the attention of the entire world. What could this amazing find in the far reaches of space be, and what does it mean for us here on Earth? There was a key moment in history when two of the most amazing space missions ever launched ushered in the era of space exploration. It was thanks to the brilliant mind of Gary Flandreau of NASA's Jet Propulsion Laboratory that an ideal route was mapped out for the probe to reach the distant planets Jupiter, Saturn, Uranus, and Neptune. With only a pencil and 21st-century engineering tools, Flandreau made a startling discovery. In the late 1970s and early 1980s, the four gas giants would be aligned in a unique cosmic configuration, creating a kind of celestial necklace with Earth. This alignment would allow spacecraft passing close to each planet to gain speed thanks to its gravity, as if being pulled by an invisible rope. Thanks to this gravitational assist, a journey that would normally have taken 30 years from Earth to Neptune would be reduced to just 12 years. However, there was a catch. This alignment occurred only once every 176 years. Faced with such an exceptional opportunity, NASA acted quickly. In just 15 days apart, they launched two identical spacecraft, Voyager 1 and Voyager 2, in the summer of 1977, aiming to take advantage of this cosmic alignment. Little did they know that these twin explorers would break all records in the history of space missions. More than 45 years after their launch, the Voyager 1 and Voyager 2 spacecraft are still operational, sending back information daily from the edges of our solar system. These probes have become the farthest traveling ships in history, having gone far beyond what was first imagined, which is impressive considering their original mission was only planned to last 4 years. However, these interstellar pioneers had plenty of surprises in store. At the start of their epic journeys, they provided incredible close-up images of the moons of Jupiter and Saturn, revealing worlds that were far more active and dynamic than anticipated. These discoveries of active volcanoes and ice fields forever changed our understanding of these distant corners of the solar system. Voyager 2, in particular, was the first spacecraft to approach Uranus in 1986 and Neptune in 1989, becoming the only probe to exist between those planets, surprising scientists with astonishing findings in previously unexplored territories. More than 14 billion kilometers from Earth, these Volkswagen Beetle-sized probes have defied all expectations and continue to expand the boundaries of our knowledge. The Voyager journey began with a gravity assist maneuver around Venus, a feat never before attempted by any spacecraft en route to Mercury, making them true pioneers. The journey to Jupiter took the spacecraft 10 times the distance from Mercury to Earth and forced them to pass through the dangerous asteroid belt, a feat previously tackled by the Pioneer 10 and 11 probes. But the challenges didn't end there. With just 69 kilobytes of memory, a fraction of the capacity of a modern smartphone, the onboard computers had to rely on their own intelligence to manage the complexity of this extraordinary journey. Data collected by instruments aboard Voyager were stored on track tape recorders before being transmitted to Earth via a transmitter that only used 23 watts, about the same power as a light bulb. These probes were equipped with 12-meter diameter satellite dishes to facilitate communications. They used lightspeed radio to send and receive messages, but the increasing distance from Earth, advancing at 3 or 4 light seconds each day, presented major challenges. One of those challenges was that signals from Voyager 2 took more than 18 hours to reach Earth, and increasing background noise from radios, televisions, cell phones, and other sources made it increasingly difficult to pick up the faint signals from the spacecraft. Despite these obstacles, the Voyager probes have defied expectations and continue to amaze astronomers with unexpected discoveries in an interstellar void. Their journey has rewritten our understanding of the cosmos, and altered our view of the unknown. Beyond our own solar system lies the enigmatic Oort cloud, a vast and mysterious region composed of trillions of icy comet-like objects that form a spherical shell around the Sun. This cloud, held together by the Sun's distant gravitational pull, extends nearly halfway to the next closest star system. Scientists believe the Oort cloud is a remnant from the early formation of our solar system, a frozen archive preserving material from billions of years ago. Despite its enormous size, no direct observations have ever been made, and its existence is inferred based on the behavior of long-period comets that originate from this distant region. Some of these comets, when nudged by the gravitational influence of passing stars or the galactic tide, embark on long journeys toward the inner solar system, giving astronomers valuable clues about the cloud's composition. Although the Voyager spacecraft continue moving ever so slowly toward this distant realm, their journey through interstellar space officially began when they crossed the heliopause, the boundary that marks the transition from the Sun's influence to the vast, uncharted expanse of interstellar space. The heliopause is a dynamic and ever-changing region where the outward pressure of the solar wind, a stream of charged particles emitted by the Sun, is finally overcome by the opposing pressure of the interstellar medium. This invisible yet crucial boundary acts as the outermost shield of our solar system, protecting it from incoming galactic cosmic rays and other forms of high-energy radiation originating from deep space. As the Voyager probes continue their slow drift into the uncharted realms of interstellar space, they serve as humanity's distant ambassadors, carrying with them the famous golden records, phonograph records containing sounds and images representing the diversity of life and culture on Earth. These records, designed to last for billions of years, hold greetings in multiple languages, music from different cultures, and sounds of nature, offering a snapshot of our world to any potential extraterrestrial civilization that might one day discover them. Despite their incredible journey, the Voyager spacecraft are not immortal. Their power sources, radioisotope thermoelectric generators, RTGs, are gradually losing energy. Scientists estimate that by the mid-2030s, both probes will no longer have enough power to keep their instruments running. Even then, they will continue traveling through the cosmos as silent relics of human ingenuity, drifting endlessly among the stars. The Voyager mission has not only reshaped our understanding of the outer solar system, but also redefined what is possible in space exploration. These small, aging probes have survived against all odds, venturing into the unknown and providing humanity with a glimpse of what lies beyond. Their journey is a testament to human curiosity, determination, and the relentless pursuit of knowledge that drives us to explore the cosmos. Let me know what you think in the comments box. If you enjoyed the video, don't forget to hit the like button and subscribe to the channel.